Hello, good evening, good afternoon, everyone. Today we are going to go ahead and talk about the kind of maths that comes in IGIDR, MSE, Gokhale, etc. Okay, so what we are going to do, beta, is we are going to start. This you should know what kind of maths comes here. We talk about limit, continuity. Then we also go ahead and we talk about some parts of sequences and series. And then, so if you look at the basic math that comes in IGIDR, uh, this is what it is about, right? Then we talk about differentiation, integration, probability, statistics, econometrics, some parts of econometrics. So what we're going to go ahead and do is we're going to start by talking about limits today. We're going to try and revise what are limits, and we are going to go ahead and see how much of it we can go ahead and reach today, right? So we want to talk about the idea of limits to begin with. This is going to act as a basic math course for all of those who are not well versed with the mathematical part for these exams, right? So let us go ahead and talk about what is the idea behind limits. Now, when we talk about limit of a function basically is what value does that function approach as x approaches a particular value. So for example, here I've gone ahead and given you an example. Let's say that the function is fx is equal to x plus 1, right? And let's say that we go ahead and ask what value does this function approach as x approaches 5. So instead of 5, you go ahead and you put, instead of x, you go ahead and you put 5 in the function. You plug 5 into the function and you get 5 plus 1. And you get the answer as 6. So the value that this function approaches as x approaches 5, that is the limit of the function, right? So as x gets closer and closer to 5, the function will get closer and closer to 6. Now, how do we know that the function will get closer and closer to 6? In order to go ahead and do that, what you can do is you can take values of x close enough to 5, but less or more than 5. So for example, if I go ahead and I take, let's say, x as 4.99999, if I go ahead and take x as that, and I put that inside the function, so it will be 4.99999 plus 1. It is going to be 5.9999, right? So if you notice this 5.9999, this is very close to 6. Similarly, let's go ahead and let's say that I go ahead and I plug in some value of x, which is again close enough to 5, but a little more than 5. Let's say I go ahead and plug in 5.0001. What do I observe? I observe in this case that the function takes the value 5.0001 plus 1, right? The function was x plus 1. So it takes the value 6.0001. Again, if you notice this 6.0001, this is very close to 6. So what we observe basically is that the function goes ahead and takes the value close enough to 6 when I have my x close enough to 5. This is very close to 6. This is also very close to 6, right? So we are approaching the value 6 when x is approaching the value 5. So something like this. X is 5. When I approach 5, I take some number very close to 5. 5, say, let's say 4.9999, or I go ahead and I take a value of x very close to 5, but a little more than 5. I'm approaching 5 from this end. Let's say 5.0001. We notice that the value of the function approaches 6. So here the value of the function was 5.9999. And here the value of the function was 6.0001. So it is approaching 6 from both sides. It's getting closer and closer to 6. Well, beta, this exactly is the concept of limit, right? So when I say limit of the function as x approaches 5, the question that I'm asking is what happens to the function as x approaches a particular number from both the sides? Whether I approach it from the left hand side or the right hand side, what happens to the value of the function? Does it approach a particular value? That is what we are asking, right? So here I have gone ahead and I have taken different values of x beta. This is x approaching closer and closer to 5. So you notice function approaches closer and closer to 6. Here x approaching closer and closer to 5. So the function approaches closer and closer to 6. Right. So let's generalize this this definition, and let's say that the limit of the function as x approaches 5 is 6. And we write it. The notation that we use is this. So we say limit x approaches a fx. This is L. This is how we go ahead and we write this. Right. Now, beta, let's go ahead and take another example here. So it says find the limit of the function here. So in order to go ahead and find the limit of the function in the simplest format currently we are doing, what we will go ahead and do, we will just put x is equal to 6. So in this function, when we will put x is equal to 6, we will get, sorry, x equal to 16, we will get the answer as 6. We will get the answer as 6. So we can go ahead and say that the value of the limit is 6. This is what we can go ahead and do. Now, so far we have been just very straightforward, and we have just gone ahead and put in the value of x inside the function. However, this is not the only thing that we want to do in limit. We want to also go ahead and we want to talk about what are one-sided limits. And when we talk about one-sided limits, that's the first thing I want to do. And we also want to go ahead and we want to talk about something a little trickier. And that trickier thing that I want to talk about is called undefined value. So what happens when the value of the limit is not defined? In order to go ahead and give you an example of it, let's say that the function is 1 by x. Let's say that this is the function. Now, in this function, the aim is to understand what happens as x approaches 0, right? Now, you have to understand that, if I just simply go ahead and I put x is equal to 0, then I will get 1 by 0. And when I say 1 by 0, beta, 1 by 0 is an undefined form. We cannot have 0 in the denominator. We cannot have 0 in the denominator, right? So when we have 0 in the denominator, we cannot go ahead and evaluate what will happen, right? So what we can go ahead and do is, in such cases, we may want to go ahead and look what happens to this function as we approach 0 from the left hand side and from the right hand side. So which means that we want to ask that, okay, and we will talk about all of this in a little detail, but we want to ask that, okay, at x is equal to 0, if I cannot define the function, if I cannot tell what it is going to be, then can I go ahead and can I ask myself what happens when it is very close to 0, but a little less than 0? It is approaching 0 from here. And what happens when it is very close to 0, but it is approaching 0 from here? That means, let's say x is 0.0001. So we are going ahead and asking the question, what happens if we go ahead and we approach from the left-hand side and from the right-hand side, right? And this is where we want to talk about something which is known as one-sided limits, right? And that is where I want to go ahead and define the exact definition of limit, right? So, so one-sided limits are basically when you evaluate it only from one side, either left-hand side or right-hand side, right? So evaluating the limit by looking at the function to the left of x is equal to 0 or to the right of x is equal to 0, when I look at only from one direction, that okay, instead of putting exactly x is equal to 0, let us go ahead and put something very, very close to 0, but a little less than 0, or very, very close to 0, but a little more than 0. When we go ahead and we do something like that, right, then this is evaluating the one-sided limits. Okay. Now, the left limit is when you approach it from the left-hand side. So you put any value which is less than whatever limit you are testing. So for example, if I want to test limit x tends to 0, then if I have to approach it from the left-hand side, I will put any x less than 0. So which means less than 0 means it can be any negative value. So I'm just going towards 0. You see, I'm becoming closer and closer to 0, but from the negative side, right? And if I were to check, so this is left-hand limit. And if I were to check the right-hand limit, then I will go ahead and I will approach this from the right-hand side. Right? So I will go ahead and I will go closer and closer to 0. You see, this is becoming smaller and smaller, and it is becoming closer and closer to 0. Are you getting it? So that is going to be the right-hand limit that I want to go ahead and test. Now, when do we say in general that a limit exists? A limit exists. This is the very important definition. A limit exists when you see that the left-hand limit exists, the right-hand limit exists, both are equal to each other. And that is when we say the limit generally exists, right? We will talk about it a little more, which should be equal to the value of the function also, which we will talk about. But the left-hand limit exists at this when we approach the function from the left-hand side. The right-hand limit exists when we approach the function from the right-hand side. And the general limit exists when what we approach from left-hand side becomes equal to what we approach from the right-hand side. Okay. So therefore, we can say that these three conditions, they have to be satisfied for the general limit to exist. Now, beta, what we can go ahead and do is, let us look at this graph that I have displayed here. And try to understand what happens in this graph as, let me zoom this a bit. What happens in this graph as x is at -1. So if I look at x at -1, we notice that the left hand and the right hand values both come towards the same. So I am approaching -1 from the left hand side. So the function approaches 1. I am approaching -1 from the right hand side. So the function approaches 1, right? And at x is equal to -1 also the function's value is 1, right? So we can say that the function limit exists. Now, beta, let us have a look at what happens at x is equal to 1. Right? When I look at x is equal to 1 and I try and approach the function from the left-hand side, the function approaches 1. But when I try and approach the function from the right-hand side, I go towards 1. See, I'm going towards 1. The functional value approaches 2. So the left-hand side and the right-hand side values are not matching. So in general, therefore, we can say that the limit of the function exists at x is equal to -1. because one-sided limits are equal, but it does not exist at x is equal to 1 because one-sided limits are unequal. Are you getting it? So this is how we are checking the limits, the one-sided limits. Now, let us go ahead and let us just try to do a question based on it. So you can just read this theory a little later. So let's go to this function now. So the function given to us is fx is equal to mod x plus 3, right? And now what we are going to go ahead and do is we want to approach this from x tends to minus 3, and we want to approach it from the left hand side and the right hand side. Now another way to go about doing this is when you say that limit x tends to 3 minus 3 minus, it means that you have to take the value of x as anything but less than minus 3. Very close to minus 3, but a little less than minus 3. So what you can do is you can put a little less than minus 3 by subtracting something from minus 3. Are you getting it? And then you can just have h approaching to 0. Is this clear? So h is very, 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 very close to 0. I am subtracting something from minus 3. Because why am I subtracting? Because I'm going towards minus 3 from the left hand side. So I am subtracting something from minus 3. Okay, I am subtracting something from minus 3 and I'm going towards close to minus 3. But because I have to be very close to minus 3, so h has to be close enough to 0. Okay. So now what you can do is better. This is minus of 3 plus h plus 3 limit h approaches to 0. This is minus 3 plus h, plus 3. This will be 3 plus 3, this will be 6. So answer will be 6. Right? Now just think about it. What happens if I want to approach minus 3 from the right hand side? But if I want to approach minus 3 from the right hand side, it means I take a value which is greater than minus 3. So I add something to minus 3, right? So just think about this. This is minus 1, minus 2, minus 3, minus. I'm approaching minus 3 from the left hand side. So when I approach it from the left hand side, I have to subtract something from minus 3. I'm approaching minus 3 from the right hand side, so I have to add something to minus 3. So this is what I can do now. I can just add something to minus 3, h tends to 0. So if that happens, because h is just very, very close to 0, you have to be very close to minus 3. So you will get minus 3 plus 0 plus 3, 3 plus 3, 6. So the answer to this question will be 6. So whether I start from the left hand side or the right hand side, we notice that we always go towards 6, right? So therefore, we can say that the limit of the function is 6. Okay, now let's take this discussion a bit forward and let us ask what happens to the function 1 by x. This is my function. So indeed, when you check that at x is equal to 0, I will just get 1 by 0. It will be undefined. So now I want to go ahead and I want to check, okay, I cannot take x is equal to 0, but I can take very, very close to 0. So beta, if this is 0, this is 1. This is minus 1, this is 1. Now I'm taking a value very, very, very close to 0. So let's take a value 0.01 negative, 0.01 positive. My function was 1 by x. So when I take negative 0.01, I will get 1 upon minus this. So minus that. So the value of the function will be somewhere very, very large, minus 100. Right? Minus 100. And when I take 0.01, it is going to be 100. Now I approach even closer to 0. Let's say I take minus 0.001. So my function value again, if you just notice here, will be minus 1000. So the value of my function that I will get is minus 1000. Minus 1000, huge. And here it is going to be 1000. Very, very large, okay? 1000. So as you keep approaching 0 from here, you keep getting negative values, large negative values, right? As you, large negative values means large in the absolute sense, minus 100, minus 1000, minus 10,000, and so on. But when you approach it from here, you keep getting large and large positive values. So ideally what this means is it approaches infinity from here. Infinity from here. And it approaches minus infinity from here, something like this. So basically, if I were to draw this function will go ahead and it will look something like this. So one-sided limits are not equal. Going from the negative side gives you minus infinity, and going from the positive side gives you plus infinity. Since these one-sided limits are not equal, we cannot say that the general limit exists. So we will say that the general limit does not exist. DNE means does not exist. Okay, beta. So let's go ahead and write down these things. So we can say that the limit exists, as we have seen. General limit exists if the left-hand side limit, the right-hand limit exist and they are equal, and it does not exist if the left-hand limit does not exist, or the right-hand limit does not exist, or they exist but they are not equal to each other. Okay, let's take another example now. So prove that the limit does not exist, and the function given to you is x minus 1 upon x minus 2 at x tending to 2. So beta, what we can see is when I put x is equal to 2, I get 1 by 0 form, which means it's kind of indeterminate. So I want to check what happens to this function when I approach 2 with left-hand side and right-hand side. So when I say left-hand side, it has to be very, very close to 2, but a little less than 2, like 1.99999. So I will get the answer as minus 10,000 when you put this, right? And when you approach this from the right-hand side, let's say 2.0001, again very close to 2, but greater than 2, you will get 10,000. So again, a situation very, very similar has come in. When I'm trying to go towards 2 with any number less than 2, it is giving me negative large and large values, right? And when I'm trying to approach 2 with any number greater than 2, close enough to 2, but greater than 2, then I'm going ahead and getting a very large positive number, right? So in one way, I'm approaching minus infinity, and from the other side, I'm approaching infinity. And because these limits are not equal, we can say that the limit does not exist. Okay, so let's now go towards this graph now. And if you can just check this graph once better, let's check what happens, say at 0. At 0, when I approach from the left-hand side, the functional value is 1.5. When I approach from the right-hand side towards this, the functional value is 0.5. The two values are not equal to each other. So the limit doesn't exist at x is equal to 0. It does not exist at x is equal to 0. Okay. So now as a homework, I want you to check what happens at x is equal to -1. Okay. Fine. So since the left hand side and right hand side are not equal, we have proved that in general, limit does not exist at x is equal to 0. Now, beta, we want to talk about the infinite one-sided limits. Now, sometimes what will happen, what we saw above is that one was giving us -infinity and one was giving us infinity. But sometimes what will happen is that both will give you infinity. That is called infinite one-sided limits. So if both one-sided limits are infinity, the general limit exists, and that is also equal to infinity. This point. Similarly, if both one-sided limit exists and both are equal to -infinity, then also general limit exists, and that is equal to -infinity. Right? But if one-sided limit exists, but one is infinity and one is -infinity, like 1 by x. 1 by x minus 2, here x approaching 0, here x approaching 2. Then we proved that the limit does not exist. So take this example. Had the function been this, limit x tends to 3, 1 upon x minus 3. Then when you would have approached this from left-hand side, you would have got -infinity. Just try and put anything less than 3 and check. Put x is equal to this. When you would have approached x from the right-hand side, you would have got +infinity. Just put anything close enough to x and check. So we would have said that limit doesn't exist. But the moment mod here, then when you put x less than 3 or more than 3, you will notice you will always get the answer as infinity. You will always get the answer as infinity. So whether you go ahead and you approach x from the left-hand side or the right-hand side, because you have taken an absolute value of it, you will always get a very large positive number. So in this case, when I'm trying to approach 3 from the left-hand side, and when I'm trying to approach 3 from the right-hand side, both ways, I am going towards the same value of +infinity. So in this case, we can go ahead and say that the function goes towards infinity from both left and right-hand side. And because of that, we can say that one-sided limits are equal, general limit exists, and it is equal to infinity. Right? It is equal to infinity. Okay, so beta, we will stop here for the day, and then we will continue with limit of combinations and try to go through that also.